from the break. So this isn't really a course where we spend a lot of time talking about terminology, or where you have an exam where we ask you what does this mean and that mean, but it is important to understand some of these terms to understand what we're talking about. So this might seem like a silly question, but what is a computer? Who wants to sort of give an answer? There's no right answer. What do people think a computer is? Yeah?
A machine that you can give instructions to.
Yeah, a machine that you can give instructions to. Do we have a chocolate?
Yes.
Are we throwing or?
Are you allergic to anything?
No.
There's no nuts in any of the chocolate. Not that that's anything people are allergic to. Okay. But that was a great answer, because it's like it's a machine that you can give instructions to. And that's correct. Does anyone else have anything else to add or say? Yeah?
It's just a thing that takes an input and gives an output based on.
Okay, yeah, it's a thing that takes an input and gives an output. Yep. Based on what the controller, yeah, that's right. So there's lots of ways we can think about a computer. I mean, and there's general purpose computers like a laptop, and then there's the computer in your microwave oven. We're more focusing on general purpose computers in this course. But, you know, it's a machine that can be reconfigured for different purposes, you know, so we can have software that makes computers do completely different things. But the key elements are a processor to execute commands and memory to store information. And we'll talk more about those two things as we start programming. Okay, so what is programming?
A set of instructions that you give to the computer.
Yeah, programming, again, another chocolate if you want, yeah? Chocolate.
This is bad.
You've got your baseball cap on to, you know, help you with the throwing. What's programming? Writing a set of instructions or step-by-step instructions that a computer can follow to, you know, solve a task. That's right. And to do that, we typically learn programming languages that help us write those instructions. Now, what does programming involve? I've said this before, it involves a lot of problem-solving skills. So, you know, maybe not in week one, but once we get further into the course, you might be spending a lot of time with a pen and paper, planning out and thinking before you just launch into type. And especially in the last topic we do, you'll be drawing diagrams and making sure you've got everything right in your head before you just randomly type in anything, right? You also need testing and debugging skills. So even if you're the best programmer in the whole world that's ever lived, you're going to have bugs in your programs. And you're also going to need to test them and make sure they're correct. And that's something that you might require many iterations to do. So you might write some code, test it, have to debug it, you know, then you test it again, debug it again. So this is normal. If this is happening to you, this is normal. You might require patience and perseverance. And also, as you do more, you get more confident that you will find the bug. At first, it can be a little bit daunting. But you just need to keep practicing. And if you are really stuck, we've got ways to help you. But you've got to get used to making mistakes. If you try and not make a mistake, you're not going to learn. Also, sometimes we purposely break our code and do bad things just to learn and see what happens. Like we make mistakes on purpose. I'll be making mistakes in this lecture all the time, both on purpose, sometimes to show you something, and sometimes not on purpose. Okay, so what is a programming language? Well, I'll just talk a little bit about programming languages or computers versus humans. So computers execute precise instructions encoded in binary. So all the instructions that computers are running are just a series of noughts and ones encoded to mean that it does different things. All the data that a computer stores are a bunch of noughts and ones. You know, the video that you might be watching, it's a bunch of noughts and ones. Data that represents, you know, the sound and the audio. This language, this bunch of noughts and ones, binary data, is not easy for humans to read and write. Back in the old days, they did write in this stuff in binary. They had to learn how to do it. But they weren't writing the complex, sophisticated software that we are writing today, where that would just be very difficult to do. Now, humans speak in natural languages that aren't precise enough for computers. So whether it's, you know, English or French or Mandarin, whatever it is, they've all got ambiguity in them. And that's not very good with computers. So we need to be able to get the computer in precise language to do something. We don't want to do it with noughts and ones. It's too ambiguous to do it in, you know, a human spoken language. Programming languages take the middle ground. They're structured and precise enough that they can easily be mapped to the noughts and ones that the computer understands. And they're simple enough, hopefully, that humans can learn them and understand them too. All right, so we write a program. In this course, we're going to be writing in C. The computer doesn't actually understand C. We go and take another program that goes and converts what we've written into noughts and ones. Okay, and that's what the program runs. So that's what you might call an executable or a binary or whatever. I don't know if you've used that terminology before. Are there any questions about that? Okay. Now, how do we run these programs? So right now, lots of us, I can see lots of laptops in the room. We've probably got lots of things running on them. I was going to say some people might be playing games, but a lot of people wrote they don't like computer games in the Kahoot. But anyway, you might be doing all sorts of things on your laptop now. I've got a browser running. I've got streaming software running, whatever. Now, so you can kind of use the analogy of cooking recipes. So if you had like lots of people in your kitchen all trying to cook recipes at the same time, what would happen if no one was in charge? It'd be chaotic. You'd have people all wanting the oven at the same time and all wanting, I don't know, the blender, whatever. You'd end up with chaos. And the same thing if we just let programs run loose on our machines. So we've got something called an operating system that manages the hardware and resources in our computer. So it makes sure, you know, one program isn't hogging like the CPU or the memory or whatever. It makes sure your game is not stealing your bank details from your web browser, all that sorts of things, hopefully. Okay, so the operating system executes programs for us, like when we ask it to, hopefully. Makes sure the programs do what they're supposed to do. Schedules them so they all have a share of the resources and can run seemingly at the same time. And also make it convenient to use. You don't have to be an expert in the underlying hardware to use your laptop. If you know how to use Windows, for example, you can use any laptop. So, hands up. So typically the most popular sorts of operating systems are Windows or Mac OS, or Linux. Hands up if you use Windows. Okay, a lot of Windows. I'm using Windows here right now. Hands up, I can see lots of Apples in the audience, so there's a lot of people using Macs. Hands up who uses Linux. A few hands. By the end, everyone's going to put their hands up for Linux because we're using Linux in this course. If you don't know what Linux is, don't worry. It's a great operating system, it's secure and reliable. It doesn't use up a lot of resources on your system. Why are we using it? We want everybody to use the same operating system, so it's very consistent and fair. It's easy for you to ask questions and get help. It's easy for us to help you when you ask questions because we're all using the same operating system. It's widely used in servers and research and development, so it's relevant in industry. So it's a really good thing to start learning. We're only going to really use a small snippet of it in this course, and then you'll learn more and more about it if that's the direction you go in. You can also look at all the underlying source code of Linux. I don't recommend that necessarily if you just are starting out in your intro, but further down the track, that's something that's great about it too. All right, now, do we know what these things here are called? Has anyone seen things like this in movies or on TV before? Yeah? Terminals. So in this course, we're going to, instead of using the GUI and double clicking and dragging and dropping things, we want you to start using the terminal. So yeah, lots of TV shows, you've got all these smart people typing in all this stuff that looks sort of very impressive. You'll be doing that soon too. So your family and friends will think, wow, they know what they're doing. They're typing on a terminal. Okay, so the terminal itself is this window that we drag around. Inside the terminal, there's just a program that's running that's sitting there and waiting for us to type in. And it's sitting there waiting for us to type something in so then it can go and do what we've told it to do. But we've got to learn what we can type into it to make it do stuff that we want. And then it'll print out stuff on the screen. I'll show you in a minute. And then in that terminal, we've got this thing that the shell prints out called a prompt. Now yours won't look exactly like this, but it'll probably have your ZID and something that represents what machine you're on, and then a $sign, which is the prompt. That means you're ready to type, or it's ready for you to type. Okay, now who's sitting here thinking, help, I don't have a Linux machine, I don't know how to get one, what am I going to do? Only a couple of people. I expected a lot of hands. Don't worry. Basically, we've got all the resources you need. When you turn up to a face-to-face lab, there'll be Linux machines. You'll log in with your ZID and ZPass. But also, you might want to work at home. We've got something called VLAB, which allows you to log in to the CSE servers, and you'll have you can access your account on your own laptop. There's instructions on how to set this up, but also bring your laptops to your first tutor lab, because your tutor can also help you troubleshoot it in the lab if you need to. So if you want to go ahead and do it before then, go ahead and try. If you're not that, if you want somebody to help step you through it, you can wait to the lab. Basically, you've just got to download some software and blah, blah, blah. But you've got the support to do that. All right, let me show you what VLAB looks like. So when you run it, you'll be downloading something called Tiger VNC. Don't worry, but when you run it, you'll get this little box and you type something in. It's all in the tutorial and the documentation, exactly what you type in this little window. Don't worry if you can't see it clearly right now. But when you connect to it, you're going to get something that looks like this. And this is what you're going to get when you go to the lab the first time, the just in-person lab. You'll get something like this to log into. And you type in your ZID, and you'll type in your password, like your ZPass. Okay. And you might get this box to click OK on. If it's the first time you've ever used it, there might be another few dialog boxes, I don't know. I've already logged in a lot of times by now. Now, this is the desktop. This is a Linux desktop. Now, if we want to bring up the terminal, hopefully you can see there's this little thing that looks like a terminal down the bottom. We can click on it. Now, I've gone in and changed colors so it doesn't look, I didn't like the black with the, other color. I wanted it like this. You can do the same thing too. Now, can people see this text or is it too small? Right at the back? Can you see it? Can people see it on the screen, do you think? Call out if you can't see it very well. So this is my terminal. Now, I type stuff in here. No, I shouldn't type that. I type stuff in here, and the shell that's sitting in there reads it in and tries to do what I'm telling it. Now, if I type in rubbish that means nothing, it'll print out an error message. What can I type in here? Well, we're going to learn that now. One thing though, I should mention, I nearly forgot, the first time you open your terminal, or it doesn't have to be the first thing you type, but a good thing to type as a one-off is this 1511 setup. So when it says type this in the terminal, it means you literally go here and type that in. Oops, I've already forgotten what it was. Setup. Okay, 1511 setup. There we go. You type that in, you only have to do this once and it goes and just configures a bunch of things that are helpful for this course. I'm not going to run it now because I've run it before and I've also got extra things set up for myself, but you'll run that once. All right, let's talk about how we can sort of do things on Linux, open files and all that sort of stuff. Now down here, I'm just going to open this little thing. Now this possibly looks more like the type of way you use your computer, I'm not sure. Does this look familiar from like Macs or Windows? So this is showing me, I'm in my home directory. That's where all my stuff is. You'll have a home directory as well. Now in my home directory, I've already got all of these. You might call them folders. We will call them directories. So whenever I say directory, you might be thinking of it as a folder. It's the same thing. I've already got all these folders in here and I can see them. If I wanted to go inside a folder, potentially I would double click it. And inside this folder, I can see there's nothing in there. How do we do this sort of thing on the command line? Well, here's a bunch of important Linux shell commands. I'll go through a few now, but they're there for you to reference later. So first of all, I can type, let me go back to here. When we log in, we're in the home directory, and this little tilde squiggly thing means home directory. If I want to see all of the files or the contents of my home directory, I type in ls, that means give me a list of the contents. And I can see the same thing that we see over here, but in text rather than with pictures. If I want to go inside a directory, the equivalent of, clicking on that directory, I use the cd command. So cd means change directory, and I can go into COMP1511 lecture, right? When I'm in there, to see what's in there, I can type ls again, and there's nothing in there yet. All right, these are the two most important things. See what the contents of the current directory are, change into another directory. I can even make another directory. Now, if I was doing it in the graphical user interface, I'd probably, work out where on the menu create folder is, and I'd do it like that. Let's just call that Monday. If I'm doing it on the command line, I use the command called mkdir, make directory. Okay, so this is how we can see the contents of our directory, change into a directory, make a directory. Now, you're going to be practicing this in labs this week. and throughout the whole course. So you don't have to get it all now. I'm just giving you an idea of how we work on the command line or terminal. Now, how can we create a file? Now, has anyone heard of the text editor vscode? Doesn't matter if you haven't. We're using that one. To open up the editor, we type in the word code and just say we wanted to create a new file. Imagine I wanted to create a file called food.txt. I could do that, and it's going to create the file and open it for me to edit. Okay? Actually, at the moment, it hasn't created the file because I haven't actually pressed save yet. But imagine I do. I would try and write healthy food. What else is healthy? Lettuce. All right, so I can type, we could just type text in here. Then we can do, you can go to the menu to save it or press Control S, and we see that that dot has gone, right? If we've edited and haven't saved, we've got that as a dot. When we save it, the dot goes. All right, that's how we can make files. Is everyone happy? Yep.
Where does this food.txt get saved?
It'll be, because I opened my editor here, in this particular directory, I typed code in here, it'll save it in that current directory by default. But like anything, we can go to here and sort of say save as and save it wherever we want.
So it would be saved in the COMP.
In the current directory where we are. Okay, so that's a very good question actually. Sometimes when you save things, you don't know where they've gone, right? That can happen. All right, that's how we can create files. What else? Oh, that's right. A few extra things. Now, if we're using a graphical user interface and we're inside a directory, if we want to go up to the parent directory, you know, there might be some button we click that takes us up to the parent directory. So imagine I go into the directory called Monday. If I want to go backwards into the parent directory, I can say cd ... That'll take me up a directory. If I want to just do the equivalent of going to my home directory, I can just type cd. And again, it's going to take practice before you remember all of this and get used to it. But these are the types of things you can do. You can use print pwd to tell you what directory you're in. It's not that helpful for me because it's already kind of printed out. Let's just change back into here again. Apologies. It tells you what directory you're in. I already know where I am. I didn't need it, but there you go. Okay, let's have a look. Three more things. How do we copy a file? How do we move it to another directory or change its name? And how do we delete it? So we'll just do those things quickly, knowing that you're going to practice them more. So if I want to make a copy of food.txt, I use the cp command. Oops, let's just call it food2 so I don't get confused. So now I've got two files, one's a copy of the other, right? So that's just copy. Now, if I decided I wanted to move food2 into my Monday directory, if you're using the graphical user interface, maybe you drag it. Here we use the move command. So I could say, let's move this particular file into this particular directory. So now it's not there, it's in the Monday directory. The other thing we can do is, I'm going to change into the Monday directory using cd. The other thing we can do with move is change the name of a file. So if we give it something like menu.txt, which is not the name of a directory, I can't type. it's going to change the name of this file to menu.txt. All right, so these are just a few basic commands that you're going to practice and get used to over the course, basically. Now, sometimes we want to delete files because we don't have infinite space to store things. If I want to remove a file in Linux like this, I use the rm for remove command, and I just say what I want to remove. Be careful because it's not going to a trash bin where you can change your mind and drag it out later. This is really going to delete it. So, you know, it's gone now. That's okay because it was just, you know, rubbish. All right. Any questions so far? I know it's a lot. But any sort of questions with what we've seen? All right. Just one more little thing. There are things called Linux flags. We can put a little -r, or there's all sorts of different ones that make the command do something slightly different. Now, if I'm trying to copy a whole directory, and that directory's got contents in it, I can't just do it with rm. I have to do it with rm -r. That can actually copy a whole directory and all of its contents. The same thing, if I want to remove a whole directory and all of its contents, I would use rm -r. Be very careful before you type that in, because you could remove a whole sort of system of files in one key press. Here, these are just unimportant files. All right, so that's your crash course in Linux, and you will get used to it. And there's a Linux cheat sheet here if you want more tips and tricks. But let's get into programming with C. So often people ask why we're learning C, why aren't we learning Python? That's typically what people say. But C is a great language to learn. Many modern programming languages are based on C, and a lot of the things you'll learn in C are going to, you know, help you learn, and you'll see them in other programming languages. The other thing is, and the main thing is, learning C actually helps you understand the underlying architecture of computers. So when we program in C, we're directly manipulating memory where we're storing our data. And often in other programming languages, you don't really get to do that. It sort of does that stuff for you. So it really helps you understand how things work, which is what we want for people who are doing computing or engineering. And Windows and Linux and Mac operating systems, the heart of them, the kernel, are written almost entirely in C. It is an important language. The other thing is, regardless of what language you're doing, that's not really even the point of this course. Like, the main point of the course is the logical thinking and the problem-solving skills, and learning skills that can apply to other languages that you learn later. So most people don't just learn one language, you'll learn other languages, and this is a really great first language. It might be some people's second language. It's all good. Okay, so here's our first C program that we're going to look at today, and I'm going to go write it and run it. And it's the first of many bad jokes and bad puns in the course. Well, maybe it's not. Maybe I've already done some already. So we're going to explain what this is, how to run it, how to create it. So let me go back to, I'm going to get rid of this. And I'm going to go to a different, oops. You don't even have to worry about what directory I'm going to. Oops. Code. Okay, here we go. Now, in here I've got a file already called helloworld.c. It's basically just a text file. I'm still going to open it in the same editor. So I'm going to type code helloworld.c. And in there, I've got this stuff written here already. Now, these are called comments. So when I've got a line that starts with 2 forward slashes in a row, like all of these lines have, they're comments. Does anyone know what a comment is? Yeah? You want to, oh, yeah? Do you want to answer?
Comments are lines which the compiler doesn't make, but it's for our convenience so that anyone else can make it. But it will not run in terms of.
Yeah, that's exactly right. Comments are there for humans to read. They don't actually run on the computer. The computer isn't executing these things. They're documentation. And you might be thinking when you start programming, well, it doesn't matter what the code looks like as long as it works properly. But that's not the case, because you'll be modifying your programs. If you were out in a job, you'd have colleagues, you'd be working on code together. It's very important to make sure your code's readable and maintainable. One way of doing that is with comments. And in this course, we have a style guide where we basically say we want this kind of comment at the top of all of our code. So when we're doing our labs, we do a comment like this. Where basically we just sort of say what the program is, who wrote it, the date, and a little bit about it. So I've just done that because this is the type of thing you want to put in all of your programs. Now, the next thing that we put in all of our programs is this cryptic thing here. Oops. Gosh. There we go. This cryptic thing here that says int main void, open curly bracket, close curly bracket. And I'm telling you now, we're not explaining this properly in week 1. Right now we're saying this is what you always need to type in. Every program needs this. It has to be called main. If you spell it wrong, it doesn't work. And that's where the program's going to start executing from. All right, so for now, we're just always going to type this in, and we'll explain in a couple of weeks more about it. The other thing we're always going to type in is this return 0. Again, we'll explain more about it later, but for now, think of this as a template, okay, for how to create a program. Now, typically, when you first learn any programming language, they always get you to write a program that prints out hello world onto the terminal or onto whatever. That's what we're going to do. Now, to do that, we're going to use a function called printf. Printf is a C function. Okay? And we can tell it what we want it to print out. So I'm going to tell it, I want you to print out hello world. Oh, I can't type. Exclamation mark. So this line here is saying, I want you to do a printf. When you do a printf, you've got to put inside these brackets and these quotes what it is you want to print. Okay, so it's going to print hello world. But in order to use printf, we've got to make sure we're including the library that printf comes from. So that's why we have this line up here, std.io.h. This is saying, I want you to include the standard input and output library. Basically, every single program, almost every single program in this course is going to have this main thing and this hash include, because we're typically printing something out or reading something in. Okay, so I've written this code. I'm pretty happy with it. I think it's going to do what I need it to do, but how do I run it? Well, you might remember me saying that the computer does not actually understand C code. written like that, the way I've just written it. We need to run a program that goes and converts that into noughts and ones that I can run. And that program is called a compiler. And the one we're using is DCC. So I type in DCC, and then I type in the name where I've got my C code. And if all goes well, it doesn't actually print out anything, but it creates this file. And the file's called a.out. That's our executable. That's the program with all the noughts and ones that the machine can understand and execute. And to run it, I type /a.out. So just this step of compiling the code, then running it, you're going to practice all of this in this week's lab. Okay, so it's very exciting when your parents ask you what you learnt today and you show them. They're probably not going to be too impressed, but yeah, you're going to get into much more impressive stuff later. Does anyone have questions about DCC or running the program? Okay. Now, yeah? Oh, yes. What if we don't like the name a.out, or what if we've got lots of programs and we don't want them all called a.out? Let me, just to remind you, let me remove this a.out file. I can make sure DCC gives my program a nice name. So instead of just typing this in, I can say put the output or put the executable in a file called hello world. I could call it anything I liked, but it's better to call it something sensible. Now, I've got the hello world.c that had the text in it that I wrote, my program. Then I've got the executable I can run like this. Okay, excellent question. Now, if you look online or whatever, you might see other compilers such as GCC or Clang, CLang. In this course, we're using DCC. It was actually developed by one of our lecturers, Andrew Taylor, and it's got a lot of inbuilt stuff that makes the error messages much better and easier for students. So anything you write, even if at home you use something else, everything for this course needs to compile with DCC. Okay, now I'm annoyed with this program. It's printing out hello world, but it's ending up on the same line as my prompt, and it makes it hard to read. So I want to make the program put a new line in. I want it to print hello world, then go to the next new line. And to do that, we use this special escape sequence, we call it, \n. \n, you'll get used to it, means new line. So if I save that, so when you modify your code, you have to press save, you have to recompile it, and then when you run it, it should have the change. Okay? And you can run it as many times as you like, but when you change it, you've got to save it, recompile it, and then run it. So this \n gave us this new line. All right, are there any questions about any of this? All right. Now, yeah?
What happens if you want to print \n?
We've got a very good question here. What if you want to print \n? And I'll show you that in 1 minute. Yeah, I will. That's a very good question. Before I show you that, I'll just quickly show you what happens if we make mistakes. So what happens, it'll happen to all of you, I leave this semicolon out, right? When I go to compile my program, and just also a little tip, every time I press the up arrow, it scrolls back through the things I've already typed in. So that makes it easier. I don't have to keep typing this DCC line in. So I'm going to compile it. I purposely made sure there was a mistake. There's no semicolon there. And I get what we call like these compiler errors. Now we've only got one error. Sometimes you could get lots of errors. Always start with the first error. Now this error is really helpful, I think. It's saying in your file called helloworld.c, go to line 12, and over here we've got the line numbers. So already I know there's a mistake on this line here. And go to column 29, and it's telling us down here that this is column 29, right? And it's saying there's supposed to be a semicolon there. So this one is really helping you a lot. You go and put it in, press save, compile, and it's all good. Oops. Now, sometimes the error messages aren't as clear. So imagine, again, I've purposely taken away this curly brace. So there's supposed to be an opening one and a matching closing one. When I compile this, it's very confusing. It's telling me actually it's on line 12, column 5. It's not as clear what's going on. It's saying expected function body after function declarator. What on earth does that mean? If I hadn't done this mistake on purpose, maybe I wouldn't know and I wouldn't be able to find it. This is where somebody asked before, can we use AI to help us find bugs? This is where we can. We've got a tool, and it says it here, called DCC Help. So if you get an error like this, you don't know where to start, type that in, and it gives you an explanation. And this explanation, I'm not going to read it all out, tells you about curly braces and is going to give you a better idea how to fix it. Now, if DCC doesn't help enough, we've then got DCC Sidekick. Now, when we do DCC Sidekick, this allows us to go into sort of a conversation and ask more questions about and clarify what the error is. Now, DCC Help and Sidekick are things that we're providing you in the course that you're allowed to use. They're things to help you learn though, and they won't be there in the exam. DCC will be there, but not the Sidekick or the Help. And you can play around with DCC Help and Sidekick yourself, but that's the basics. Now, we've got 5 minutes, so I'm going to answer the question. Somebody had a really good question. What if you really wanted to print out \n and it's always just doing a new line instead? Or what if you just wanted to print out \? We've gone through all of this stuff. We call like the \, an escape character. And when we do \n, it sees the \, it looks at the end and goes, oh, you want a new line. If we put a \, then a T, it'd say, oh, you want a tab. A \, and a quote, oh, you want to print out a quote. Now, why would we need \, quote to print out a quote? Well, the quotation mark itself has a special meaning. So if I wanted to actually, you can see that when we run this, it doesn't print hello world in quotes. Those quotes are part of the language. What if we did want it to print those quotes? Well, when we do this, C gets confused because it usually looks inside the quotes to see what you want to print, and it sees a pair of quotes with nothing inside it, and then there's all this extra stuff. So if you actually want to print a quote, you do a \, quote to show, I just want you to print this quote. It's not part of the C language. It's a quote I want you to print. Oh, I haven't put my curly brace in. Back in. Okay, so now we've got those backslash quotes. We should actually see some quote characters. Oh, I put it after the new line. Ugh. Okay. There we go. I compile it again. Okay, and then I run it. And it prints out hello world with quotes around it. Now, if I want to print out a backslash is a special character. So in order to print a backslash, I've got to put backslash to say, don't look at this backslash and then the character after it to work out what it is. Please print a backslash. So let's just do that. Now, most things aren't this confusing when you're just trying to print stuff out. But yeah, these special characters are. Yay. And you will, that's a great question. You will be doing that in the lab this week. All right, I think that's all we've pretty much got time for. I hope you enjoy your lab this afternoon if you've got one. I'll see you all tomorrow from 4 to 6 online only. Thanks everybody. Thanks so much. Bye. Yeah. Hang on, I'll just start packing up a bit.